You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Server Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Operating system and software problems are among the most common sources of server outages and administrative frustration. These problems include login failures, failed service starts, broken patches, and bootloader errors. They affect user authentication, application uptime, and overall server behavior. In many cases, software problems appear as hardware faults due to system crashes or kernel panics. The Server Plus certification includes identifying and resolving these software-level issues to restore normal operation quickly and safely. Software and operating system errors may look like memory problems, disk failures, or network outages. A reboot loop caused by a bad driver may resemble a hardware failure. A corrupted user profile may mimic permission errors or network disconnects. Logs, update histories, and configuration records are essential to distinguish between true hardware faults and software misbehavior. Technicians must always eliminate software causes before replacing physical components. Login problems occur frequently on both Windows and Linux systems. Users may receive errors such as user profile cannot be loaded or authentication failed. These may be caused by account lockouts, expired credentials, corrupted profile data, or misconfigured authentication modules. On Windows, review login events in Event Viewer. On Linux, examine authentication logs, the secure file, and relevant journal entries to identify the source of login issues. Issues with domain authentication and ticket-based access protocols such as Kerberos also cause widespread login failure. A common Windows error is a broken trust relationship between the server and the domain. This may be due to time drift, machine account corruption, or a missing secure channel. Use tools such as NLTest, Kerberos List, and the Active Directory Users and Computers console to test and repair these failures. Patch and update failures are a frequent source of boot problems and degraded system behavior. On Windows systems, errors may result in boot loops, missing driver support, or stopped services. Logs such as the component-based servicing log and Windows Update log provide troubleshooting data. On Linux, check logs such as yum-log, apt history log, or system journal entries to find patch-related failures. Look for messages that indicate incomplete transactions or broken package chains. Rolling back failed patches must be done cautiously. Windows systems support rollback using system snapshots or the deployment image servicing and management command with the revert pending actions option. Linux systems that use the Butterfile system or timeshift tool may roll back both kernel and application updates. Always test rollback procedures in staging environments to ensure compatibility and integrity before using them in production. Software conflicts may emerge after patches are applied. This includes applications that fail due to removed dependencies, version mismatches, or updated libraries. Logs often show missing shared objects or invalid modules. Use tools such as List Dynamic Dependencies, System Trace, or Dependency Tree Review to track which versions are expected and which are currently installed. Resolve conflicts before restarting services or reapplying updates. Kernel or driver mismatches are another risk after patching. If a new driver does not align with the currently running kernel, the system may crash or fail to detect critical hardware. In Linux, use the bootloader to select a previous kernel if needed. In Windows, use Advanced Startup to revert to the last known good configuration. Always track which kernel version is running and which drivers were changed during the update. Misconfigured bootloaders can result in errors such as missing operating system, no bootable device, or grub rescue prompt. These problems often appear after an update that modifies partition layout or device identifiers. Use recovery media to reinstall or repair the bootloader. Tools such as grub install, bootrec, or EFI shell utilities may be needed. Always confirm that the correct universal unique identifiers and mount paths are set in the boot configuration. Services that fail to start after an update may signal permission changes, missing binaries, or outdated configuration files. On Windows, use the Services Management Console, Event Viewer, and the Service Control command. On Linux, use System Control Status, the System Journal, and the Execution Trace option to isolate the problem. Restart services manually and verify logs to confirm recovery. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Reviewing uptime and reboot logs is important when diagnosing software-related instability. Unexpected reboots or sudden shutdowns can indicate problems introduced by a patch, a failed service, or a corrupted driver. On Linux systems, use the last command, who-b, or check system journal entries to correlate the time of reboot with patch installation. On Windows systems, examine the system event log for shutdown events, update completion, or rollback entries. These timelines support root cause analysis and trend tracking. Proper patch scheduling and testing are essential for stable server operation. Updates should be deployed first to staging systems that mirror production environments. Use centralized update systems such as Windows Server Update Services, System Center Configuration Manager, or Red Hat Satellite to manage patch rollout. All patching procedures must include a rollback strategy. Change documentation should identify which updates are planned, which were applied, and what testing was performed. Vendor patch advisories should be reviewed before applying any update. Microsoft, Red Hat, and other enterprise vendors publish regular bulletins detailing known issues, compatibility notes, and post-installation tasks. Watch for known bugs that affect your current software stack or kernel version. Delay deployment if the advisory includes issues that match your environment. Do not apply updates blindly without reviewing release notes. Support staff must be trained to read and interpret patch logs. This includes showing technicians where to locate update history, logs for failed installs, and command line tools for investigation. On Windows, this includes viewing the component-based servicing logs or the Windows Update history. On Linux, this includes viewing the advanced packaging tool logs or the system journal. Provide real-world examples of update failures in training labs to support hands-on learning. System recovery options must be configured in advance of patching. Dual boot kernel configurations, safe mode boot entries, and fallback bootloader options allow recovery when an update causes system instability. Schedule patch-related reboots during times when technicians are available to monitor the result. In critical environments, configure watchdog timers or automatic rollback mechanisms to limit risk. Monitor systems carefully after patching to detect any regression. Symptoms of degradation may include high processor usage, increased disk wait times, or background services entering failed states. Compare system metrics before and after patching to confirm that performance remains consistent. If regressions occur, document the changes and report the findings to the vendor support team. Silent failures may go undetected without proper monitoring. All software modifications must be logged for audit and compliance purposes. Track which packages or updates were applied, when the change occurred, and who authorized or executed the update. This information must align with change control documentation and audit policy. Archive all update logs in a centralized system with role-based access control to ensure accountability and traceability. Avoid untracked manual patching wherever possible. Installing packages manually or editing system libraries without documentation creates risk. All changes should be logged, scripted, or applied through configuration management systems such as Ansible, Puppet, or Chef. One-off fixes must still be recorded and reviewed. Systems that lack traceability cannot be supported or audited effectively during outages or investigations. In conclusion, software-level problems require structure, observation, and careful planning to resolve. Login failures, patch issues, and service errors are common but manageable with proper processes. Documentation, rollback planning, and staged deployment prevent simple problems from becoming disasters. The next episode explores software dependencies, library version mismatches, and techniques for resolving conflicts introduced during updates or package changes. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.